In this section, we'll cover filter optimization techniques, including choosing the right filter types, applying filter options, and using common filter alternatives like set and parameter actions. Goals for this section include reviewing Tableau's filtering order of operations, introduce general optimization tips and best practices for specific filter types, comparing various types of date filters and their performance impact, and exploring filter actions along with their alternative approaches such as parameter and set actions. Now that we've talked high level about filtering and performance, let's take a deeper dive into the filtering order of operations. Filter operations happen at different levels and have varying performance impacts in your Tableau workbook. This process is reflected in the order of operations by which all processes are conducted inside Tableau. Order of operations controls the sequence in which all computations, actions, or filters are executed. Note that this diagram covers most, but not all parts of Tableau's order of operations. Let's take a quick look at each part. First is extract filters. Extract filters are only applicable when using extracts and are applied on extract creation or extract refresh. Data source filters are the highest level filter available besides extract filters. Data source filters apply to the entire data source for all worksheets and views. Context filters are dimensional filters which are elevated above traditional dimension filters. These filters are often used to impact top-end type functions and were originally thought to improve performance. Results may vary in terms of performance with context filters, and they shouldn't be relied on to improve performance. Dimension filters are simply filters that utilize a dimension, limiting the data coming into your dashboard. Measure filters are created by using measure fields to apply filters to your sheet or workbook. Table calculation filters are filters which leverage table or window calculations in your visualizations. Note that since these are based off of table calculations, they'll only be computed inside Tableau and not inside your data source. In between each of these main filters, you can see different things such as sets, conditional filters, level of detail calculations, forecasts, and more. Note that order of operations isn't just reserved for filtering. All processes in Tableau follow an order of operations. Each of these can impact performance in either a positive or negative manner. Extract and data source filters are mostly positive impacts to performance by cutting down data at the source. Context, dimension, measure, and table calculation filters require more thought and precision in their application. In the next lesson, we'll dive deeper into filter types and their impact. There are many ways to optimize filter performance in Tableau, including general and type-specific best practices. First, let's go through the general best practices. The first best practice is to limit the number of filters that you're using. Limiting the number of filters on the dashboard is the first and most often beneficial step to managing filters for efficiency. The more filters on your dashboard, the more complex the queries are going to be that push back to your data source. You should also try and limit filters with large lists. Discrete filters with large lists of values can be resource intensive for Tableau to process, especially in combination with other filters. Tableau will need to query the entire source to populate a unique list for the dimensions in question. Try using other types of dimensional filters like custom value lists or wildcard matches instead. Next, you should try and avoid level of detail expression-based filters. LOD-based filters leverage LOD calculations and apply them on the filter shelf. As LODs can be resource intensive depending on what grain you're bringing them down to, basing filters off of them should be avoided. Try using sets inside calculated fields as an alternative to level of detail-based filters. You should also try and avoid user filters whenever possible. User filters have several drawbacks. First, they limit Tableau's ability to cache and can increase the size of the data greatly, which adds extra processing load on Tableau. If user-level filters can't be removed or pushed back to the data source itself, try having the security level bubbled up to a higher level dimension than the individual user. Instead, maybe you can aggregate up to city or state. Now let's look at some type-specific best practices for filters. First are context filters. Context filters used to be recommended to increase performance in prior versions of Tableau. This was due to their ability to create temporary tables, which isn't how they work now. You should only use context filters for your specific use case if it merits them, such as a top N or another type of feature. Dimension filters are the most common filters applied in dashboards. One of the best ways to optimize dimension filters specifically is to include the dimension you are filtering on in the sheets themselves. This will prompt the data used in the filter to be queried already just by generating the view. While measure filters are less common than dimension filters, you can still improve their performance by opting for range type filters rather than discrete drop-down lists. And finally, table calculation filters. Since table calculations are computed in Tableau directly and are not pushed back to the data source, using them as a filter can exacerbate their negative performance impact. Try using other dimension or measure filters that don't leverage table calculations. Now that we've talked high level about some filter optimization tips, let's jump into Tableau Desktop and apply some of these best practices to our own workbook. Alright, so we're back in Tableau Desktop and we're looking at our Tableau Desktop Performance Data Design Workbook. The first thing we're going to do, since we're in a new section of the course, is save another version of this workbook. We're going to call it Tableau Workbook Performance Filtering Optimization. So we'll go up to File, Save As. We'll change from Data Design to Filter Optimization, and we'll save our workbook. We'll make sure that we save on our Start Here tab so that when we open this up later, we can do some performance testing. Now let's go over to our dashboard and review what we have. One of the big things you notice about this workbook when reviewing it quickly is the sheer number of filters being applied. Let's go ahead and remove a bunch of filters which we don't think will help answer the question the dashboard is supposed to answer. Remember, our question is, what is the safest path for a cyclist in New York City? Going along that same vein, there are some long discrete list type filters in location, latitude and longitude, and unique key record ID. These don't really have a practical application as a filter, so we're going to want to remove them as well. You'll see at the bottom of the dashboard, there's a bunch of number of measure filters, which we won't need. So let's start with those with the cleanup. We're just going to go ahead and X those off of the screen. You'll notice our dashboard computing every time we take one of these off, and it can be a pretty long process. So one thing that we can do here is go ahead and pause our data source while we're doing this, and we'll turn it back on once we're done. So we'll hit pause auto updates. We'll go over, we'll hit pause again on this so that we pause our actual filter. And you'll see that when we're removing these now, it's not computing every time. So we'll just remove all of these number ofs from our view. There we go. All right, so we've got all our number ofs out of there. We also wanted to get rid of our location, latitude, and longitude and our unique key record type filter. So here's our unique key. We'll go ahead, get rid of that. And you can see our location up here. We're not going to be searching by latitude and longitude. That doesn't make a lot of sense. So we'll take that one off. Now let's take a quick review of our other filters. We've got borough, year of date, zip code, on-street name, unique key. We're going to want to take that out. So we'll get rid of unique key. We won't be searching by unique key at all. Contributing factor, vehicle 2, cross-street name, off-street name, vehicle type code 1. Those all seem okay, and there's not too many of them. We'll be optimizing them more later on, but that's looking okay for now. Down here, this is a parameter, so we're going to leave that alone, and we'll talk about legends later on, but that's pretty good. We've gone ahead and removed a bunch. Let's go ahead and go to our map sheet. I think that's where we're generating all of these filters. If you don't know, when you generate filters in a dashboard, they always come off of one sheet, but you can apply them to others. So let's go and see if this is our source sheet. Yep, looks like it was, and we've got them all off of the filter shelf, which is good news. Those are all global filters, so the cool thing about global filters, if you want to take them off, all you need to do is click on it and drag it off, or delete it like we did before, and that will pull it off of all of the sheets that we're looking at. It's a handy way to clean up the dashboard. And even if they weren't applied globally, if you're just removing them, you could always apply them globally and then remove them just to make sure that they're off of all the sheets. And you don't have to go to all the sheets and do that individually. So that's a pretty easy way to do that. And a lot of what we just got rid of were measure filters, but they were discrete and drop downs, which makes them worse performing. So we definitely wanted to get rid of those. Now, to make sure that all of the existing filters are still applied, let's just go ahead and hit our drop down. And we'll say apply to all using this data source. We only have a single data source, so we're going to want to apply those. So we'll just go on each of these filters, say apply to all using this data source. That way later on when we're optimizing, it's just doing it on every one of our sheets. Okay, almost there, just a few more. All using this data source. And okay, all right, that's pretty good. Let's go ahead and turn our dashboard back on. So we're just gonna hit play on our updates. All right, that's already loading a little bit better. We do have it cached, but still, that's feeling a little bit better. And if we look at our filter shelf, that's looking pretty good. Some of those filters were in context. Now they are not. They're all just normal filters. You know, context isn't necessarily going to hurt, but it's not going to help either. So we're only going to use context when we need to for top filters and things like that. Dashboard's looking pretty good now with a lot less filters. Let's go back to start here and we'll save our workbook. And now that we've talked through our filter optimization, we're going to dive into filter option choices and their related performance impacts. Customizing filter options can improve both real and perceived performance in your dashboard. Let's take a quick look at some different filtering options. One of my favorite filtering options is using the Apply button. While the Apply button customization option isn't a performance enhancer, it will do two things. Number one, users can get confused that the dashboard is broken when they deselect all from a filter. When they do this, the dashboard will blank out and they think they did something wrong. Apply buttons hold the action until the selection is chosen, and then it applies the filter. Number two, without an Apply button, the dashboard will load each and every selection that the user makes on the filter. This can be tough for users who are investigating many different facets of the data rapidly. It will be much more advantageous if they can select a bunch of different options and then execute a query. Next is using ranges rather than discrete lists. Range type filters will perform better than discrete drop-down lists because Tableau won't have to query all of the data to pull a unique list for the filter in question. You might need to convert the field to a measure to do this, but when you can, it's a good idea to do so. Next is using wildcard match and multiple value custom lists. Using wildcards and custom list filters removes the need for Tableau to query the entire dataset to create a unique list. In these options, the user is responsible for finding the values and can interface with just the search results alone. Finally, limit the use of only relevant values. Only relevant values is an excellent referential filter feature, but you should use it with caution. If there are a lot of filters, this can be non-performant. This is because when this option is selected, the list in the filter box will reference other filters being applied in the dashboard. I always err on the side of using only relevant values in my dashboards, but when I'm really trying to cut down on my performance, I will take a look at doing this to see if it does any material improvement to my dashboard. Now that we've talked through filter options at a high level, let's go into our workbook and apply some of these in our own dashboard. All right, we're back in Tableau Desktop and we're looking at our Tableau Desktop Performance Filter Optimization Workbook. Let's go ahead and go to our main dashboard and we'll modify some of the filters that we have. Now it should be noted that when you're doing your filter options, you always want to modify them on the dashboard, because if you modify them in the individual worksheet, a lot of times those mods aren't going to transition to your dashboard. So even if you do an apply button on your individual worksheet, it's not necessarily going to transfer over to your dashboard. So always customize your filters on your dashboard so that you can avoid doing that multiple times. All right, the first thing we're going to do is go ahead and add an apply button for pretty much all of these dimensional filters. That'll make it much easier for the users to interact. So we're going to go ahead, hit our caret. We're going to go down to customize and we'll say a show apply button. So we'll go ahead and do that for all of these. Should be relatively quick. We're not even going to need to pause our dashboard to do this. So we'll go down, customize, show apply button. So we'll go customize, show apply button for all those that we have available right now as drop downs. Apply button. All right, so for on street, cross street, and off street, we're going to want these to be multiple value custom lists. I think right now, oh yeah, there we go. We've got multiple value custom list here. Let's double check that these aren't right in wildcards. We don't want wildcards, and I'll show you the reason why. We want to make sure these are multiple value custom lists. There we go. And wildcards aren't bad. They're actually really performant. It's just with wildcard, you type in a value and it will find it, but it won't tell you what values it found, and it'll be hard to tell what you're filtering on. With a multiple value custom list, I could type in Main for Main Street, and I could hit the little search icon, and it would give me all the options that it came up with, and I could just pick the one that I want to see, right? So that makes it a lot easier. If I go ahead and undo that, now I'll show you what would happen if I did a wildcard. So if I hit wildcard match and I type in main, you're going to see something a little bit different than what you saw with the custom value list. It's not going to bring me back a list of, the related field that I just typed in. It's just going to filter down and choose those fields that have main in them, but it's not going to actually show me what it picked. So it's still good, still fast, but doesn't give me that option. So in my opinion, not as good as a multiple value custom list. I'm going to X that out to release this filter. I like the multiple value custom list because it's got the search feature, but it doesn't have, the drawback of not being able to see what you're filtering on. So that's why I prefer those in there. They're just a little bit easier for the end user to use. All right, so let's take a look at our street filters. We don't want only relevant values for these. We want all values in the database. Because we are using this search functionality, we don't really need relevant values. It's just going to pick the ones that we want. So if we do all values in database, that'll just populate it with everything. But we don't really care. It's not a drop-down list. It's not going to make it easier for us to read. By making these all values, that just makes it easier. Tableau's not trying to filter down a list for us or anything like that. So that's definitely a nice thing there. We want to do that combo whenever we can. If we're using our pick lists, we might want only relevant values to make them a little cleaner. But if we're using something like a wildcard or a multiple value drop-down search like this, then we want to do that. All right, that's looking decent now. Let's go ahead and we'll go back to start here, and we're going to save our workbook. And now that we've talked through our filter options, we'll be diving a bit deeper into filtering dates specifically in the next lesson of the course. Date filters include their own set of unique options, which can materially impact performance within your dashboard. There are three primary categories of date filters, including relative dates, range of dates, and discrete dates. First, let's look at relative date filters. These filters are middle of the road in terms of performance, neither the best or the worst. The main benefit of this filter type is user experience and usability. The concept of showing the last number of days, months, or years off of today's date brings great value to the end user and the developer. This one filter allows a developer to maintain a trailing dynamic history without data manipulation, calculations, or repulling the data. It's also very customizable to the end user, who can change their perspective at will. Next is range of date filters. This is the fastest filter option in terms of raw speed, due to the continuous range dates. Note that this type of filter leverages a min and max function on the back end. Its usability is fair, but can become more cumbersome to control using specific dates and sliders. Discrete date filters are the worst performing type of date filter. The combination of the filter's use of date part functions to break out pieces of a date and Tableau having to create distinct lists to view in a drop-down make it very non-performant. Try to avoid these types of filters if at all possible. One of the biggest differentiators between performant and non-performant date filters is the use of date part versus date truncate functions. Date truncation is a faster method of querying date-related data in Tableau, as opposed to using date parts. Date parts like month, day, year can be resource-intensive to perform, especially if your database is partitioned by date part. If date parts are used, be sure to extract your data and materialize your calculations afterward. This will help solidify the date parts as part of the functional structure and will avoid some recalculation. Now that we've talked about date filtering at a high level, let's jump back into our workbook and apply some of these topics. Okay, so we're back in our Tableau Desktop Performance Filter Optimization workbook. We're going to go to our Map tab, and we'll modify some of our filters. Let's go over to Map and let that load. Alright, so if we take a quick look at our filters and our dates, we can see that we do have a date filter on here, and it's the year of date. But we also notice that this is a date part function, which is less efficient than a date truncation function or relative dates. Let's go ahead and modify this a bit. So we'll right click on our year of date, and we'll go down to More. We're going to go over to Custom. We're going to do Date Value. We'll click OK. Then we're going to switch over to a relative date. We're going to want years. Let's do a pretty good relative date. We'll do a last 2-year rolling. And we're going to anchor this to a specific date. Because this data set is a little bit old, it's not going to work with a standard relative date, but we still can use our relative field to do this. So we can go ahead and lock this in at a prior date. So let's go with December 31st, 2015. That's the end of this data set. We'll click OK, and that filter should apply. Now you'll see how this changed to be a continuous filter. We'll go ahead and right click and say Show Filter here. We're just going to refresh our data for a sec to get our filters back. Sometimes they can go away a little bit. If that ever happens, you just lost connection for a quick second to your data source. You can just hit the refresh and it'll all come back. Then we can see that we don't have that drop down with just the years anymore. We have a very nice relative date filter here, and we can change it to be whatever we need it to be. It's really customizable, but we have it anchored to our end date, and that's looking a lot better. The other thing we want to do is just apply this to everything. So we saw we lost that when we modified the filter. That's okay. You can just click on that caret, go down, apply to worksheets, all using this data source. All right, and you'll know that that worked if we get that little cylinder on the left-hand side of that filter. We're probably going to end up using some filter actions or set actions to apply this mainly on the dashboard, but it's always good to have this relative filter out there. We also notice that we have this number of persons injured on here, which is okay. It's a measure filter. That's just fine. But if we look at our dashboard, I don't think that's on there on the right-hand side anymore. We might have gotten rid of that. So we're just going to want to go ahead and add that back in, just so that we can have that one continuous measure. I think that's a good value to have. Pretty quickly, we're just going to go over and click on our map sheet, and then we'll go to the top caret on the right-hand side, and we'll go ahead and add that back into the dashboard. All right, so we'll just go ahead, hit our caret, filters. We want sum of number of persons injured. I'm going to want the second one. The first one, that's a table calculation. Can't really tell that from here, but I just know that because of this workbook, so we'll click the second one. Okay, and we'll just click off of our main view of our dashboard, and we'll hit the little refresh button, just so that all of our filters appear so that we can see that that filter worked. Like I said before, sometimes with your dashboard you lose a little bit of communication with your source. This is especially true when your dashboard's really slow like this, so you're going to have some wonky stuff happen when you're trying to work with the workbook. But we're getting closer to having better performance on this, so that should happen less and less. So now we're just going to go ahead, go to Start Here, we'll save our workbook, and in the next lesson we're going to be going through filter actions and their application and performance factors. Filter actions are an app-like dynamic alternative to using discrete filter dropdowns. Because they leverage dimensions already used in the dashboard sheets, these filters will not add additional load to rendering or processing and are inherently faster than normal filters. They can easily be integrated into your dashboard but require tuning in order to make them perform optimally. Looking at the filter action menu, you can see that there are various options for our filter actions. Each will have a trade-off between functionality and performance, so choose wisely. First, let's look at source sheets. Source sheets represent the sheets where the action is derived. So if you click on a mark on a sheet, the action will be carried out. It's recommended that for each action, you should choose a single source sheet. Next is Run Action On. This is your action's behavior. Will it be triggered by hovering, selecting, or selecting via a menu? Hovering is discouraged as it will generate too many queries. Users can also be confused by the hover action as they won't know when they're actually generating the actions on the dashboard. Select and Menu Select are the best choices in terms of performance. Though Select is a favorite of mine, as it lends itself to what most users are used to using apps and other programs. Next is Target Sheets. These are the sheets which will be impacted by the action. Normally, these will default to be all sheets, which will result in a slower action. You should think about your user's action path. Think of a Z-pattern dashboard where you start in the top left, you go to the right, then you go to the bottom left, and then to the right again. You should only be impacting the dashboard sheets necessary and following that path. Note that whenever you add a new sheet to a dashboard, the actions will automatically apply, so you'll need to go back in and remove them as you go along. This is why adding filter actions is best done at the end of development. That way you don't have to go in and keep changing things. Next is the clearing selection. Here, show all values is the default action processed when releasing a filter action. While this option is the most common and expected among users, it's also considered the least performant because when the filter is released, all marks and values will return to the view. If it fits your use case, try leveraging the Keep Filtered Values or Exclude All Values options, as those are a bit more performant. And finally is our Target Filter section. The Target Filter section will allow you to choose which fields are leveraged in the filter action and which sources will be impacted. By default, this will be set to all fields, which will use all dimensions to push the filter action. Let's look at the difference between all fields and selected fields quickly. While all fields make sense from an ease of use perspective, sheets with a lot of dimensions will try and use all of these in the filter action created, which can slow down the filter and your sheet. It's recommended to always define your actions using selected fields. This will help performance and will allow you to directly control the impact of the filter action. If you go in and customize your selected fields by choosing the Add Filter option, you'll have a few more things you need to define. Customizing the field selection will allow you to do a few things. First, you'll be able to choose the field that you're pushing, and second, you'll be able to push your filter either across a single data source or across multiple. From this menu, you're really going to be determining the from and to fields and the data sources which will be impacted by your filter action. A quick pro tip is to use Exclude All Values for clearing a selection in order to create a show hide functionality with your sheets. Using this method, you can also improve performance by having certain sheets hidden initially when the dashboard loads, such as having a detail sheet. This sheet will only appear when the correct filter actions are accessed, resulting in a more efficient query and less data being displayed in the detail view. This will also avoid the detail view from being displayed when you first open up the dashboard. Now that we've talked at a high level about filter actions, let's go into the dashboard and modify the filter actions that we have. Alright, we're back in Tableau Desktop and we're in our Tableau Desktop Performance Filter Optimization Workbook. The first thing we're going to want to do is go ahead and clean up any existing filter actions that are in our dashboard. After that point, we can go ahead and add any new actions needed. Let's go ahead and go to our dashboard to start, and then we'll look at our dashboard action menu. To get to our menu, we'll go up to Dashboard, go down to Actions, and take a look at what we have. Let's go ahead and update our first Filter 1 generated filter action. We'll just select on it, choose Edit, and we'll take a look at what's going on. Okay, so it wasn't very descriptive as to what this action was, and that's because it's an automatically generated filter action. These come up when you click the little button in the top right-hand corner of your sheet to add a filter action. It's a great feature, but it doesn't give much definition as to what you're doing with it. If we look down, we can see that this is coming from the map. So this is really a map filter. So that makes sense for our source sheets that it will be a map filter. The select option makes sense for our run action on. That's pretty straightforward. But let's take a look at our target sheets. We can see that our map is going to be the filter, and then we have all of our KPIs up top. But we want to follow that Z pattern across and down for just our drill down sheets, and we don't want to blow back up to our KPIs because that'll be a little confusing. So let's go ahead and deselect all of our KPI sheets as our targets. So we'll just go in here, we'll uncheck all our KPI sheets. That will be all of these sheets up here. Then we can see that we have all fields selected. We do want to help define that just so that we can have a cleaner filter action here. I'm going to go ahead and click Selected Fields. We'll choose Add Filter, and we're going to just use Burrow to blow across because we're actually going to clean up the grain of this map eventually once we get to the visualization part of this course. But to start, we'll just clean up the filter action. So we'll go ahead, we're going to define Burrow as our filter that we're going to push across. And there's only one data source, so we'll click OK. And that's looking good. If we were pushing a filter action that didn't have this field in particular, it'll give a little error down here and say, this isn't here, so I can't push that filter. then let's go ahead and rename this. We're just going to call this burrow action because that makes a little bit more sense as to what it's doing. Okay, next up we'll go to filter to generated. We'll choose edit. And we can see here that we are pushing from table vehicle types. Okay, that makes sense. That's this one right here. And it's pushing to a bunch of different sheets. All right, let's go ahead and deselect all our KPIs again because we don't want that to push to the top values. We can do that with our filters, but we don't want to do that with our filter actions. So we'll go there, and then we'll go to our selected fields. We're going to add a filter here, and the filter that's going to be pushing here is going to be our zip. Let's go ahead and find our zip. So it'll be a zip code field. We'll click OK. You'll notice that it says missing field on table vehicle types. That is okay. We can actually create this filter and it won't hurt anything. We're going to go ahead and be modifying this sheet later on when we do our visualization changes, and we're going to have zip on there. So that will work once we do that. For now, we're just going to go ahead and rename this, and this should be all set for when we do those changes. We'll call this a zip action, and that's looking good. Let's go ahead and hit OK. Then we'll go over to filter 3 generated. We'll choose edit. And we can see here that this is coming from dangerous months. That's this one in the bottom left-hand corner. We scroll down, we can see that we are impacting those KPIs. We're going to want to remove those. But what we're going to actually want to do is just pretty much remove everything except for this bottom right sheet, because we are moving in that Z pattern. So this sheet would be impacting these 3. This sheet in the top right would just be these 2. This sheet in the bottom left would just be this one on the right. So we want to have that path filtered down and not blow back. It can be really confusing to the end users if you've got a sheet down here in the bottom right that's blowing back to everything. They don't know what they have or haven't clicked. So this will help with that. So let's go ahead. We're just going to deselect everything, and we're just going to keep table street level metrics. So we'll go ahead and delete these, and we can actually just use a shift and a click, and it'll take all those off. So we've got table street level metrics. We're using a select. We're doing show all values when we deselect. We've got dangerous months as our source sheet. We'll go over to selected fields. We'll add a filter. So we're going to go ahead and choose month date. We'll click OK there, and that's looking pretty good. We're going to rename this. This is going to be called month action. We're going to redesign this sheet a little bit. It's just going to be pushing our months over to the right-hand side for our drill down right there. We'll click OK, and then we have filter for generated. Now for filter for generated, we're going to actually need another sheet to be pushing from this sheet right here down to it. And for that to happen, we're just going to hit OK, and then we're going to start with our new sheet, and then we'll come back and modify this. At that point, we'll be able to add the action in. So let's go ahead and create a new sheet. We're going to call this sheet Detail Table Hidden View. So we'll go ahead, Detail Table Hidden View, enter there, and we're going to add some fields in this order. So we'll start with unique key. We're just going to double click, and we'll add borough, on street name, cross street name, zip code, contributing factor. Then we'll want number of cyclists injured, number of motorists injured, and number of persons injured. Now, just a quick note that this is a really bad sheet performance-wise. This is showing almost 1 million marks, lots of rows, and some few columns here. This is pretty much the worst performance-wise that you can do to a sheet. But the good part about this is this sheet's not actually going to show up on the dashboard until we've filtered really, really far down in our data. So it's actually not going to produce a very big query when we do it. But right now it is particularly bad. So if it's pretty slow when you made it, that's the reason why, but it won't be when we're finished. So let's go ahead and go back to our dashboard. We'll go back to Dashboard Actions. We'll click on Filter for Generated, choose Edit. The target sheet is going to be Detail Table Hidden View. The clearing action will actually be Exclude All Values, so that means that this sheet will basically disappear when we click off of this sheet, which is exactly what we want. We don't want this to load when we haven't drilled down and gotten to this last section. We're going to go and do our selected fields. We'll choose Add Filter, and this is going to be On Street Name. So we'll choose that, hit OK, and we'll name this Detail Action so that we know this is for the drill down detail. We'll say detail action there, hit OK, and we'll hit OK once more. Then we'll go over to our start here. We'll save. And up next, we'll be diving into parameter and set actions. Filter alternatives like parameter actions and set actions can provide similar functionality while improving workbook performance. Parameter and set actions are created from the same menu as filter actions and operate in a similar way, but instead of being applied directly to the filter shelf, they will impact their corresponding parameters or sets. Parameter actions will push dimensional values from sheets into parameters, which will impact calculations and filters. Set actions will push dimensional values from sheets into sets, which will also impact calculations, filters, and marks. Since sets and parameters can be integrated into calculations, filters, or directly applied against marks, it makes them customizable and multifaceted, while also being more efficient than regular filters. Sets and parameters are executed quicker because of the way they are applied in VizQL and the Tableau order of operations. Remember that there are some limitations to sets and parameters. Base sets and parameters must be created first before creating actions. Parameter actions are single select only and can't accept multiple values. Now that we've talked about parameter and set actions at a high level, let's jump into our workbook and apply some there. Alright, so we're back in our Tableau Desktop Performance Filter Optimization workbook. We're going to add one more sheet as a year selector to our dashboard to make it easier on our users and to help integrate some of the parameter and set actions that we talked about. First, let's add a new calculation. We're going to go over to our date field. We'll right click and we'll choose duplicate. Then we'll go ahead and edit this new duplicated field and we're going to name it year. Our calculation is going to be a date part. We're going to do a year of date. So we'll just wrap year around date. We'll go ahead and hit OK. Then we're going to create a new sheet. We'll go ahead and name this sheet year set. Hit enter. Then we'll go ahead and drag our new field over. I'm going to drag this to columns and drop it in there. You can see our years have come in. Then we're going to do a control or command select, depending if you're on a Mac or not. And we'll drag it to text and we'll let go. So now we have our titles and we have our labels. We're going to go ahead and hide our header. So we'll right click, uncheck show header. We'll right click. We're going to do a little bit of light formatting now. So we'll go in, we'll go to our border section. We're going to remove all borders and lines from this view. We don't want it to interfere with our later design. And we'll remove our color background as well. We're going to go to our text. We'll hit the three dots to get into our main menu here. Make sure that's center aligned. We're going to change this to size 12 and we'll make this white. This will make more sense later when we change our design, but for now, just follow along, apply all these settings, and it will look great when we're done. We'll hit OK there. And it doesn't look like the center alignment 100% took, so we'll right click, format, go to alignment, and we're going to force it. So we'll go ahead to our pane right here on default, hit center, and you can see that's now center aligned. We'll go down to tooltip, and we're just going to get rid of our tooltip. We're not going to need that. All right, and that's looking good. You can see it if you click on it. Looks great. Now we're going to add a set action so that this filter is going to apply a little bit more efficiently. We're going to right click on our year field. And you'll see if you go down to create, we can create a set directly from here. We'll click that. We're going to choose all. This is okay to be called a year set. That's just fine. And we'll hit OK. Now we have our year field and we have our year set. So that's looking good. Let's go back to our dashboard. All right. Looking good. We're going to go ahead and we're going to drag our year set in floating. So we'll just click floating here. Drag our year set in. We're just going to kind of shove it in the top right corner for now. Don't worry about where it is. We're going to do a ton of cleanup on formatting a bit later, but we'll put that up in the top right-hand corner. Then we'll right-click. We're going to hide our title, and we'll just do a fit entire view, that bottom right-hand caret. Then we're going to go back to our dashboard actions. We'll hit dashboard, actions. We're going to choose add action, and instead of a filter, we're actually going to go and say change set values. So this is where you create a set action. Click that there. We're going to call this our year set action. We'll go ahead and we're going to deselect all of our sheets except year set. That's going to be our source sheet. We want this source to action when selected, so we'll leave select there. Our data source is Bike Maven data. We're going to assign values to the set, which makes sense. The set in question is the only set we have, year set, and clearing will add all values to the set. That's just fine. We'll click OK on that. Click OK on this menu. Okay, now we're just going to go to our map sheet, and we're going to apply our year set as a filter. So we'll go ahead, and we don't even need to make a calculated field for this. We can just drag our year set into our filter shelf. Okay, we'll right click. We're going to apply to worksheets. We'll say selected worksheets, and there's a reason for this. We don't want it to impact year set because that's where we're actually driving our set action from. So that would be a little confusing. So we'll go ahead and we're just going to pick everything except that one right there. That should be just fine. And we'll hit OK. All right, now we're going to go back to our start here. I'm going to hit save, and that's perfect. So now we have our set action created, and that's going to be able to be leveraged on the main dashboard for our end users to quickly select between the two years that we have in our data set. And it's going to be faster than a regular drop-down filter, and also faster than a regular filter action. Now, before you go ahead and move on to the next lesson, what we want you to do is go ahead and save your workbook, close all of the workbooks on your desktop, and run a performance recording on your own. You're just going to go in here into your workbook. After you've closed everything, you'll open this back up. You'll go to Start Here. You'll go over to Help. You're going to do a Start Performance Recording. You'll move over to your dashboard. You'll hit Stop Performance Recording when you're done. And then you can go ahead and do that a few times to get a good range of performance for your workbook. In the next lesson, we're going to review our own performance results, which should be similar to what you have, but not quite exact. Now that we've gone through our filter optimization section of the course, let's go ahead and review the performance on our workbook so far. Our testing as of the data design section came in between 24 and 28 seconds. In our own workbook performance testing, runtimes for this section were between 18 and 20 seconds. This came in at an improvement of between 6 to 10 seconds, which is about 25% improvement. This was a good amount of improvement, and we expect to have continued improvement in our next two iterations with calculations and visualizations. Some of the improvements that we made in filter optimization included removing extra filters, those especially with long lists, changing filters to multiple value custom lists, removing relevant value conditions, optimizing filter actions, and leveraging set actions. When looking at our event type ranking in their raw aggregated form, we can see that one of our biggest areas of concern were query compiling. This has been almost completely eliminated by optimizing our filters. We've also seen some reductions in other areas, such as executing queries. The bars may look just as big as they did in prior performance recordings, but if you look at the numbers, they're getting smaller for the individual queries and rendering times. In the next section of the course, we'll be diving into calculations and how to optimize them.